Hi there, and welcome to this lesson. In this lesson, we're doing linear equations, and under linear equations, we'll be learning change of subject formula. Now, as the lesson progresses, if you have any issues at all, anything comes off as unclear, please feel free to get in touch. Okay, we would be more than happy to help. Okay, so let's jump right into the lesson. So linear equations, change of subject formula. Now, change of subject formula, what is this about really? And I have this circle. Okay, so I have this circle here, and basically I have a circle with a radius r. Okay, and basically if we were looking to find the area of this circle, we basically go a equals pi r squared. Okay, basically the formula for the area of a circle is a area equals pi r squared. Now I tell you that at the moment the subject of this formula is a, because we're using this formula to solve for a. Now what if we had an instance? Okay, so we have this circle here, and basically this time we're given the area of the circle. Okay, and we're asked to find the radius. Okay, the radius r. Okay, so this time the radius is missing, so basically we will need to solve for the radius. So what is the formula for finding the radius of a circle when the area is given? Now that's pretty much what we'll be learning about in this lesson, change of subject formula. Now what we'd have to do is we would have to reverse the area formula. Okay, so a equals pi r squared. We would have to work that formula to give us a new formula that we can use to solve for the radius of a circle when the area is given. And how would we go about doing that? It's actually very similar to solving a simple linear equation. Okay, and basically I have this here. It says make r the subject of formula in the formula a equals pi r squared. Now we have that a equals pi r squared, and just like you would when you're solving a linear equation, what we're trying to do here is we're looking to get r on the left and everything else on the right. So we're basically looking to eliminate everything surrounding r. Okay, now at the moment we have pi multiplying r, okay, actually r squared, but basically we have pi, and we would want to get rid of that pi. Okay, and here's how we go about doing that. We divide both sides by pi. Okay, and once we've done that, we end up with a over pi equals r squared. Okay, so we're getting closer to getting r on its own. Now we don't have r on its own, we have r squared. Okay, and how do we get rid of the squared? Now to get rid of a square, we find the square root of both sides. Okay, just like you, if for example if you're having 2 multiplying r, you divide both sides by 2. If you have r squared, you find the square root of both sides. Okay, if you have r cubed, you find the cube root of both sides. If you have r to the power 4, you find the fourth root of both sides. So basically we're going to find the square root of both sides, and basically the square root of r squared gives you r, so it just cancels out. What you have in the end is r equals the square root of a over pi. And yes, that is it. Basically we now have r as the subject of our formula. So if you were given a question where you're asked to find the radius of the circle with the area given, you'd basically just input your information into this formula. Okay, input and find, basically you find the square root of a over pi, and it would give you the radius of that circle. Okay, so let's go ahead and solve some examples. Basically we have a very simple formula at the moment, a equals pi r squared, but they often come in more complex form. Okay, so I have this one, and basically it says make f the subject of formula in the relation v equals u plus ft. Okay, this is still fairly simple. Okay, and we just go ahead and do that. So basically we have v equals u plus ft, and we're looking to get we're looking to make f the subject of formula in this case, i.e. get f on its own and everything else on the right. Okay, so f on the left and everything else on the right. So we have v equals u plus ft. I believe you'd agree with me that ft equals v minus u. When you move u over to the left, and basically you just switch them around so that ft is on the left. Okay, so we have v equals u plus ft. we want to move, we don't want that u there, so we want to move it over to the left, and basically we end up with ft equals v minus u. Okay, so now that we've done that, the next thing we want to do is, you probably guessed it, okay, because we don't want that t there, we're going to eliminate t, so we're going to divide both sides by t, okay, and you'd end up with f equals v minus u over t. So if you're ever looking to solve a question like this with the formula v equals u plus ft, and you're actually looking to solve for f, the formula you'd be using would be f equals v minus u over t. Let's do another one. Example 2. And example 2, now this looks a bit more interesting. So example 2 says, if p equals the cube root of q multiplying r minus t over 15, make t the subject of formula. Okay, let's jump right into this. The first thing we want to do here, looking at that, basically p equals the cube root of q multiplying r minus t over 15. I think we'd want to get rid of that cube root, okay, and basically we do that by raising both sides to the power of 3. And once we've done that, we end up with p cubed equals q multiplying r minus t over 15. Now that we've done that, the next thing we'd want to do, okay, so we have p cubed equals q multiplying r minus t over 15. Let's expand the bracket we have on the top there. So p cubed equals qr minus qt over 15, okay, and then let's cross multiply, and basically we have 15p cubed equals qr minus qt. Okay, we're getting closer and closer to having t on its own, and now that we have 15p cubed equals qr minus qt, we're going to move qr over to the left, okay, and basically what we'll end up with is we have qt equals qr minus 15p cubed. Okay, now that we have that, I think you probably know what we're going to do next. We're just going to divide both sides by q, and finally you're left with t equals qr minus 15p cubed over q, and that is your answer. It's actually very simple. They sometimes look complicated, but basically if you know what you're doing, you shouldn't have any problem solving questions like this. You just solve it like you would a standard linear equation, okay, and just try to work your way to getting the whatever you're told to make the subject formula on the left and everything else on the right. Now let's do another example. Example 3. And example 3 says, if k equals mn over x plus x multiplying a plus n, make n the subject of formula. Now this is a very interesting one, and I'd like you to pay close attention. Now we have this formula, k equals mn over x multiplying a plus n, and you've been asked to make n the subject of formula. Now, like I said, the general idea is to get n on the left and everything else on the right. But if you look closely, you'd find that we have two n's in this formula. So how would we go about doing this? Because I'm not quite sure which n to work towards, or we're often not quite sure what n to work with. But I tell you, there's a trick, there's something you can do about this, and basically at some point we're going to factorize, okay, just keep that in mind. Now, but going to that, let's just work like we would. So we have that, and basically we're just going to expand what we have on the bottom there, okay. So k equals mn over ax plus xn, okay, and then the next thing we want to do is we want to cross multiply, okay. So k equals ax plus xn equals mn, okay, and now next thing we want to do is we want to expand, okay. Generally when you have a question like this, okay, with two, like we have here, we have two n's and we're not quite sure which n to work with, just expand as much as you can, work it and expand the whole expression as well as you can. So basically right now we have kax plus kxn equals mn. Now at this point we're going to try and get all the n's together, okay. So mn equals kxn mn minus kxn equals kax. Okay, so basically every term in the equation that contains n we want to get together, so mn minus kxn equals kax. Now what would we do at this point? Now, like I said before, we're going to factorize at some point, and what I'll do with the expression on the left, I would factorize it using n. Okay, and when I factorize what I have there using n, I have n multiplying m minus kx equals kax. And now I'm basically going to go ahead and divide both sides by m minus kx. Okay, and basically m minus kx will cancel, and then I have n equals kax over m minus kx. Notice we actually have one n now, and basically that was as a result of factorizing that expression. Okay, so basically anytime you're faced with a question like this where you're told to make something the subject of formula and there's more than one instance of that term in your expression or in your formula, basically you just work expand as well as you can, and then get all the instances of that term together, factorize, and everything else is pretty much standard. Okay, so let's do, I think we have a few more examples. Now, example 4. And example 4 says if minus x over a plus 1 plus y over b equals 1, make y the subject of formula. So, basically, very simple. Minus x over a plus 1 plus y over b equals 1, and we want to get y on the left and everything else on the right. And basically, first thing we want to do, we'll move x over a minus x over a plus 1 over to the right, and we end up with y over b equals x over a plus 1 plus 1. Okay, and then the next thing we want to do, basically, I think we'll just work what we have on the right, bring it all together, and then basically we have a plus 1, just working the fractions on the right, and we have a plus 1 as our common denominator, and we're left with x plus a plus 1. Okay, and basically that's that, and we have y over b equals x plus a plus 1 over a plus 1, and we just go ahead and cross multiply, and when we do that, we have y multiplying a plus 1 equals b multiplying x plus a plus 1, and then we divide both sides by a plus 1 because we want to get rid of the a plus 1. We don't want a plus 1 on the left, we just want y there, and we divide both sides by a plus 1, and we have y equals b multiplying x plus a plus 1 over a plus 1, and that is your answer. Very simple, very straightforward. Now I think I have one last example, example 5. Okay, and example 5, it's a very I think I've done this question before, and it's a very interesting one. And basically I have this formula. I think this is a formula in optics. Okay, but that's by the way. And we have 1 over u plus 1 over v equals 1 over f. Okay, and basically we're looking to make v the subject of formula. Now we have 1 over v equals, basically we move 1 over u over to the left, over to the right, sorry, and basically we have 1 over v equals 1 over f minus 1 over u. Now some may be tempted to basically just switch things around at this point and go v equals f minus u, and they would be completely incorrect, okay, to do so. And but then how do we go about doing this? So basically we have 1 over v equals 1 over f minus 1 over u. What we want to do is we want to work the fraction on the right, okay, and basically we have uf as our common denominator, and when we work the top we have u minus f. Okay, so 1 over v equals u minus f, and now we have basically at 1 over v equals u minus f we have two fractions, two fractions on each side of the equal sign, okay, as opposed to having the sum Okay, and then basically we can now go ahead and switch the fractions and go v equals uf over u minus f. And then yeah, that would bring us very simple work there, and that would bring us to the end of this lesson. Okay, change of subject formula, very simple lesson. Basically it's not too different from solving a standard linear equation. Basically you're just looking to get your subject to formula on the left and everything else on the right. And yeah, bye for now.